In this video, I'm going to walk you through lesson 3 of unit C1. So in lessons 1 and 2, we really came to realize that carbon dioxide is most likely the cause of increasing temperatures and increasing sea levels. And so we brainstorm how adding more carbon dioxide is going to cause the temperature to increase. So this is the slide that will prompt students to stop and jot their thinking, and also gives them a hint about thinking about carbon dioxide as a mechanism for warming, as well as prompting students to talk to a partner. Then we're going to use this handout to plan the investigation with students. Now you will see that students will create an investigation question. They will also use this scaffold for completing a hypothesis statement using the if-then format. We're going to go through some reasoning with students, there's slides to support this, and then they're going to set up a data table. And this data table will be scaffolded using an anchor chart. And so you can see that we're going to read through the procedures. We're not coming up with our own procedures, but students will read through the procedures. And basically, we're going to be filling three different bottles with different amounts of carbon dioxide. So we add water, the same amount to each bottle. We use the same types of bottles. So we're controlling a lot of the variables. We're going to mark the bottles control, low, and high. The procedures say to add 2 Alka-Seltzer tablets to the low CO2 bottle. You're going to use regular air in the no CO2 bottle, and then 4 tablets in the high bottle. You can try this out in the prep section. I do talk about, you can reduce this to half. It still works. Also in the prep, I'm going to talk a little bit about that position of that bottle really matters, of how close it is to the heat lamp. So we're going to do this investigation and collect some data in our data table about the temperature increase every 2 minutes in these 3 different bottles. And then we're going to compare our data. So after students conduct the investigation, we're going to come back together and summarize our findings. And so first you're going to have them write on their own and complete the prompts at the end of their investigation handout to start organizing their thinking. And then they can discuss it with a partner, what they just summarized, to help us get ready for our discussion. Now, during our discussion, as we share our understandings and our findings, we're going to build a consensus model. And that consensus model is an energy model like we've been building. And so the objects are represented by the boxes, the system boundaries represented by the dashed lines. So we have the heat lamp as the object that is providing the energy, which is light, coming into our system. And our system is the bottle with the CO2. We've got some heat leaving the system as well. And so as heat energy to the surroundings. And so we consider this energy model for our bottle system. And then we're going to apply that same model idea to the Earth. So then we're going to apply how the energy transfer model would be different if we wanted to show how atmospheric CO2 affects ice melt on the Earth, and how the model would change if there were more CO2 in the atmosphere. So our second energy model will look like this. So we've got this, instead of the heat lamp, we've got the sun bringing light energy into our Earth system. And so we're considering what happens to the CO2 and the CO2 particles speed up, and then how that energy from the CO2 particles is going to be transferred to the ice, which means that the ice particles are also going to speed up because it's warming the ice. And so we're starting to kind of think through that lens of energy and matter using the energy model diagram. So then we're going to, now that we're starting to think about CO2 and ice melt, we're going to read an article about atmospheric carbon dioxide. And we've seen some of these graphs before. one looks like this. This had ice melt on it before, but we're looking at carbon dioxide, and we're going to introduce a few terms. And so concentration is one of them. You can see right here. We're also going to be talking about pure substances, mixtures, and solutions, and thinking through the lens of particles. And so when a pure substance, all the particles are the same. A mixture, you've got a blend of particles. And then a solution is where that salt, for example, is dissolved into the water. So it is a mixture, but it's now together instead of separated in the mixture. And so we're going to be thinking about different concentrations of gases, and we're also looking at molecular structures for the first time. So we've got a little chemistry peeking its way into our earth science, and we're going to be thinking about all these different atmospheric gases. And then there are, not here. So the handout doesn't have questions, but there's a slide that will go along with this reading, and they're going to write summary statements at the end of each section of the reading. So you're going to read a section, they're going to write a summary sentence in their notebook and a question they have about that section. So at the end of the entire reading, they're going to add another summary statement and a question they have. It's just a literacy reading strategy to help us better understand how the composition of the atmosphere changes over time and how these changes affect temperature. And so after we have recorded our summary statements and our questions, we're going to add some of those new words to our personal glossary in our notebook. There are several of them, and they're going to be talked about in the prep video. Some of them they're listed right here: concentration, mixture, solution, greenhouse effect, and greenhouse gases. And then after we introduce those words to our glossaries, we're going to discuss some key ideas from the reading and ask some new questions. So we're going to basically share out what we wrote in our notebooks. Okay, so that is lesson 3. This is a big hands-on opportunity to do the carbon dioxide investigation, although it is a bit temperamental with data collection. So the prep video will talk more about that next.